Hello everyone. Let's do today's LeetCode question. Today is Friday. Happy Friday. I will quickly charge my laptop and let's start now. Convert sorted list to binary search tree. So given the head of a singly linked list where elements are sorted in the ascending order, convert it into height balanced binary search tree. Okay, so it should be height balanced. Height balanced means that all the leaf nodes are in the same level. And one possible binary search tree which represents um just a second. Okay, the number of nodes is in the range, so it can be empty as well, and node value can be negative, 0 or positive. There can be mean multiple answers, and I should return one possible answer. Okay, got it. But how to convert it? Let's think. So if we are given a single linked list, I need to convert it into height balanced binary search tree. um since this is sorted, so what I was thinking is, first of all, I can just uh I'll just treat this as a array first, because I can convert link this to array, so that it will be easier for me to think. um and okay, I have a list of array which is sorted in ascending order, and I need to convert it into a height balanced binary search tree. If I'm looking at this array, then I'll just draw a binary search tree first. So it's minus 10, and this will be greater than this, greater, every element will be greater, right? So it should be, if this is a root, then minus 3 should be on the left side, and oh sorry, minus 3 should be on the right side, and 0 is the right side. So it will always be, if I just draw tree like this, just make child of uh just make every other node a child of the previous node, then um it will be a skewed, right skewed binary search tree. I need to create it a balanced tree, right? So it means that I need to start from the middle element, because I need to create a height balanced binary tree. So if I go to the middle, then if this is 0, um yeah, so um if if the mid element is the root, then it means that all the elements before the mid element will be on the left side, all the elements after the mid element will be on the right side, right? So it will be balanced that way. Yeah, and even for so the mid element will be the root of the tree, and the left to the mid element will be its left subtree, and right to its the mid element will be right subtree. And so this will be on the left subtree, and even for left subtree I will do the same. To find the root of the left subtree, I'll do the mid element, find the mid element, that will be the root of the left subtree, and continue like that. So yeah, so my algorithm is, if I'm given an array, then I'll just find, the mid element given an array, given an ascending array, the mid element is the root, and the left to mid is the left subtree, and right to mid is the right subtree, right? Okay, I'll do this and repeat. So if I yeah, so this is my mid element. Now minus 10 and minus 3, this will be my left subtree. So for this left subtree, if this is a mid element, then minus 10 will be the root element now, and it's left and right. So if this is a mid element, then its right will be the right subtree and left will be the left subtree, but there is no any left, so it will be null. And there is a right subtree, so there is right, so this will be minus 3, this will be a root. Yeah, I mean, if array is null, I mean that means that if it's left, so it will start from left and right. So um if array is null, then so in the beginning here L and R will be there, and if this is a mid element, then to go to the right, then R will be here. So L will always be 0 and R will always be equal to array dot length minus 1, right? So if this is the situation, if right comes before, if right is less than R, then it means there is no array. It means that there is no array left, and in such situation we should assign root to null. Otherwise we'd continue finding the mid element and assign root and assign mid element to root. Right? Okay. So in this case also, if this is a mid element, then its left will be the left subtree, but when we are going to left, then right will come here, so it means that there is no any array. So in such situation we will, so this is a base case basically. Okay, I'm also cooking a curry, so 1 city. Base case excitilagio, base case if R is, yeah, so this is my base case, basicity. Base case if R is less than R. I'm a bit diverted by my curry. I need to turn off the gas and come back again. So just as I will come back in 2 minutes. I'll turn off the stove. I'm back. Otherwise we would continue finding the mid element and assign element to root. So yeah, that's it. This is the best case. Assign root to null. Okay. Let L is equal to 0, R is equal to array dot length minus 1, and I need to go to the kitchen again and check. Okay. L is equal to, okay. So first of all, I will do that until function. So it's like I'm doing it recursively, right? First of all, I'm finding mid, and then left for the left, for the right. So it's like, I think I should use a recursion tree like structure. So it will be L and R. First of all, I'll call the L and R, and so first of all, constant mid will be equal to method floor L plus R divided by 2. And if oh yes, I also need to pass a node or what, I don't know, because I'm creating a tree, so tree is tree node. Constant node is equal to tree node, new tree node node dot value mid. So array, so we should also convert linked list to array arr. And if array mid, oh, what am I doing here? So first of all, I should check if r is greater than l, you know, if r is no if if r is less than l, if l is less than r, then we should assign then we should return null. Otherwise we would do constant, current node, or we can say root node. Root dot left is equal to something, and root dot right is equal to something, and we would return root at last, right? So this recursion, this will so this function is like this function will return the root, find root. So this is a find root function, and this function would return the root for all the tree. So this root is equal to new node, and we would just assign root dot value is equal to it is equal to array mid, right? So this is our value, and left will be, so root dot left will be equal to find the root of left subtree, right? So we need to find the root of the left subtree, and for root dot right we need to find the root of the right subtree, right? So how to find the root of the left subtree? So find root of the left subtree would be L comma mid minus 1, right? Because if 0 is the root, then root of the left subtree would be minus 10 minus 3 is root, right? This will be on the left subtree. So for going to the left, we are doing L comma mid minus 1, and for going to the right we will do mid plus 1 comma r. and so this will return a root of the left subtree, right? So we are passing the arrays range here, and if it is nothing then it will return null. So yeah, so it means that -10 -3, if it is just -10 -3, then first of all it will be -10, and it's the left subtree, it will return null, and the right subtree it will return 3, because for the left subtree uh, r will be less than l, and for right subtree it will be l and r will be equal. Yeah, -3. So if it is just -3, then l and r will be the same, and -3 is left subtree will also be null, right subtree will also be null, because for finding the right subtree it will be, will for going to the right it will be for going to the right we would do mid plus 1 r, right? Mid plus 1, yeah, so it will be l, r is less than r, and for going left also we would do mid plus l comma mid minus 1, that is l comma mid minus 1, so that is r is less than l here also, so it will return null. Okay, I think this would work. I can just return. So first of all I need to convert linked list to array. For that one I need to list, and then while add I need to array dot push add dot value, okay, array dot push add dot value, and add is equal to add dot next. So this will give me all the value. If add is null, then array will be empty, l will be 0, r will be equal to array dot length 0 minus 1 minus 1, so r will be less than r, and it will just return null. But if it is greater, then it will find the mid and assign it to root node. This will be root node, and return root at last. Yeah, this would work. Okay, it worked. Great. Thank you for watching.